Let's talk about HMI methodology and SCADA design. One of the leading concepts right now in SCADA design is called high performance HMI. And high performance HMI is not necessarily a new concept, but it's still very common to see traditional HMI screens like the one shown in many plants. Lots of operators are used to seeing things like this, and lots of engineers are used to making it. So the motivating factor behind this idea is how can we better display our data? We want things to be intuitive. We want to have a deeper look at our data and have more dimensions to our data. We want to be able to have a plant that requires less training for our operators, and we want our operators to be more effective. It was talked about somewhat, but probably not enough, that we also want our plants to be safer. There are many accident case studies that attribute poor HMI screens to workplace accidents. When operators have better data, they will have a safer plant. So let's take a look at some of the things that you might see on a traditional HMI screen. We have some pumps, we have gauges, we have some analog indicators for some transmitters, 7-segment displays, gauges, toggle switches. And I think the reason why you see a lot of the things displayed this way is because that's what the operators are used to seeing in their plant. If you walk out to a transmitter, you might see a 7-segment display, you might see a gauge, you might see a toggle switch on a pump, things like that. So I can totally understand the wanting to display things like the way that you're used to seeing them, but I don't think it's a very good argument for designing your SCADA application. So let's start by looking at analog values. Here we have some analog values associated with this transmitter, and they're just showing the instantaneous value at that point in time. We don't know if this is high, we don't know if it's low. Without any training on this application and this process, I don't know if this value is good or bad. Down at the tanks, we have a gauge to the side that shows the level, and here we get a little bit better in that we're showing, hey, here's your low point, here's your high point. We can see, oh, maybe this tank is just barely getting past that high point, but that's about the extent of it. These gauges over here, they show where its limits are, but we still don't know if this is a good value or a bad value. Other things that we see on the screen, flashing indicators, lots of use of color to show different things. This type of valve might look silly to you, but I've worked on water treatment plants where it was called out in the spec up to 8 or 9 different colors for different states of a valve. And so every color of the rainbow was in this valve to show different states, and it required lots of training for the operator to recognize and know what all those things were. So let's go ahead and take a look at what a high-performance HMI screen might look like. So the first thing that you might notice here is the use of color. The color palette for this screen is dramatically different than what we saw on a traditional HMI screen. Things have been flattened, a lot of things are much more muted, things are a lot more gray. We do see a little bit of blue here. It's a very light blue to show design ranges for these objects. But other than that, we don't see any bold colors except for this red here and here. We see a yellow alarm over here. So very quickly I can identify, oh, here's where some problems might be. And so the use of color in a high performance HMI screen is to quickly show where your problem areas are. And without any training on this application, I can look at these objects and see, okay, here's a critical alarm. I can see that this pump is commanded on, it's not coming on, and it hasn't been on for a while. I can see by the spark line here. Down at this object down here, I can see that this tank level is at a high state. It's been up above the desired range for quite a while now. Further, if I know that this valve is the valve that affects the level of this tank, I can see it's all the way open, but I can see that it hasn't been open until very recently. It's been slowly creeping up, but it only just got there. So maybe something needs to be tuned better on this valve to have it open up quicker. And then again, we can see that this is this valve has a medium alarm. I can see that it's in hand or manual, and maybe that has something to do with the critical alarm over here. So we're able to very quickly diagnose problems in a plant with this type of setup versus a traditional HMI screen. I chose not to have any animation on the screen. You can certainly use blinking animation for critical alarms of things of that nature, but we should definitely stay away from using animation for normal operating states, like things that are running. For these motor states, we're just going to use white for on and dark gray for off. and these are in contrast with the background of color that we chose. So the reason why we don't want to use color in these motor states is that these are normal operating conditions for this plant. These pumps are probably supposed to be on, this pump is supposed to be off. I don't need to use color just because things are on and off. I only need to use color when something is not doing what it's supposed to be doing, or if there's a problem. The other thing that we need to be aware of when we're designing HMI screens and using color is that color blindness is a real thing, and especially in an industry that's as male dominated as industrial automation, color blindness is dominant in males. There's probably going to be a decent number of workers interacting with this application that are either have some level of color blindness or maybe not even aware that they're colorblind. So looking at this screen, I'm actually colorblind, and looking at these red and green states for these motors is actually really difficult. And versus when we look at this high performance HMI, there's no question about what's on or what's off. And it's also pretty intuitive as well to see what's running. The next major thing that you might notice on the screen is the use of trends or spark lines. Next to almost every analog value I have on the screen, I have a spark line. If there's one thing that you can take away from this video, is to go and put spark lines next to everything. I don't care if you don't do anything else in this video, put spark line values next to all of your analog objects if you can. You're hopefully already historizing this data, and this is how you're going to use it. So if we look back on our traditional HMI screen, we look at an analog value, we just have this first dimension of data where we just have the instantaneous value, and then we move into the second dimension of data with this analog type indicator where we show this is where it's supposed to be, this is where it is now, these are the problem areas up here. And then the spark line is a third dimension of data where we can see what it's been doing and anticipate probably what it's going to do. If we look at Rockwell Automations, they have a PDF online of about high performance HMI, and here's some different trends that you might see in situations that you would be able to anticipate with. And so here we have a trend. They have its 2-hour window. You usually want to set your spark lines to about an hour or 2 hours. And we can see that this value has been exactly where it's supposed to be for a really long time. But now it's starting to slowly creep up, and it's moving towards this alarm state right here. So we can try and anticipate that and correct it before it hits it. This next trend screen shows that this has been pretty close to where it's supposed to be. It's been moving up and down and oscillating a lot. So something needs to be fixed here to try and smooth this out. And then again in this last one, we have something that was close to where it's supposed to be, then something upset it. It spiked over the alarm briefly, overcorrected, went back down, and now it's back to where it's supposed to be. But now it's starting to creep back up again. So maybe it's gonna over compensate again. So maybe something needs to be fixed here to flatten that out. Next, you might notice the type of objects that we're using on this screen are very different. We're no longer using big illustrations of what you might see in the field, because these aren't really offering any information. That's great that this might look like some of the transmitters in the field, but using these everywhere, that's probably not what they look like everywhere, and it's not really giving us any information that we don't already know. If I need to know what a transmitter, what its model is, I'm going to look that up somewhere else, not in my SCADA application. So we just need to show where this point is reading. If you really want to know, if you really want to have some kind of indication of what kind of transmitter that is, you can maybe make a little symbol like this that shows, hey, this is a temperature transmitter. Here we have some motor icons. We flatten these out and use these for state. The inner icon showing what the command is, and the outer icon showing what its status is. For objects where we're not showing any state or information, we want to make these things the same color as the background, so that we show, hey, this is just an object just depicting some just general information about where these other objects are doing. If you really need to, you can use color for your piping, but try to make that as muted as possible so it doesn't distract from the bold colors of your alarms. Over here, we took that large fan object that was in the previous screen. Here, we've made that a lot smaller. Just use this square here to indicate its state. And the remaining area that was taken up by the object before, well, we can put a spark line in there to show what this process is doing, or maybe what that fan is doing. The other things you might notice are we have some different types of charts on the screen. Here's a radar chart where this inner area shows where a value should be, its desired area, and then the outer area being its high limit. So we can quickly look at this group of objects and see things are close to where they're supposed to be, they're way outside where they're supposed to be, or they're way under where they're supposed to be. Here's another graph I've made to quickly be able to see which objects are within spec and which are not. And this is a good tool for being able to quickly diagnose which values are doing what they're supposed to be doing. Next thing you might notice is the background. I think a lot of integrators already use like a gray color to reduce the impact on the operator's eyes or people who are looking at the screen all day. I want to try and make that a little bit more yellow to reduce the amount of blue light for the eyes. It makes it a little bit more easier to look at and puts less strain on the eyes as you're looking at it all day. Next, we'll just talk about the hierarchy of all of our screens that we have. So we'll break those down into different groups and call them levels. And so at the very top level of our application, we have level 1 screens, and you might just have 1 or 2 of these, and these are your main overview screens, and they show all the critical different areas with all the critical different values. And again, trends and spark lines are super important here, so I can quickly say, hey, this guy has been where it's supposed to be for the last 2 hours. It looks like things are doing pretty well. I can quickly see that there's a problem. And again, the use of color here quickly lets me know this guy is out of spec, but overall, this maybe is doing well. So level 1's big overview, just maybe 1 or 2 of those. Level 2 process unit control, these are where we drill down and look at the different areas of our plant. Here we're looking at a single reactor and all the associated things of everything feeding it and going out of it. And then level 3, this is where we look at a very small subset of information. We have just a motor, everything associated with that. And then you might have your level 4, which might be your pop-up windows, where we click on just a single value, and that's where we can set high and low values and stuff like that. Something that I hadn't realized until recently, that's an easy mistake to make, is we shouldn't be making pop-up windows that ever cover any part of our screen, because again, we want to be able to quickly see, hey, there's an alarm here, there's a problem, I need to do something about it. So when we do need to look at an individual value, we can have a kind of docked window that doesn't cover up any of our screen, and this can either be permanently docked or temporarily docked, but don't have it as an actual floating window that covers up what you're looking at. So now that we've looked at some of the different key advantages of a high-performance HMI system and the type of effectiveness and the advantages that we get out of designing screens like this, how does this work in the real world? So unfortunately for us integrators that have gone and trying to implement these types of strategies in our SCADA applications, we do get a response fairly often to these types of screens, and that response is, everything is gray, it looks really boring, the salespeople don't like it. And I really don't have any other response for that other than that it's really stupid. This isn't an application for your mobile phone, this isn't a video game. We're not here to make something look very pretty. Honestly, I think this screen looks way better than the traditional HMI screen, but okay, you want to see lots of color, the salespeople want to see stuff really pop, whatever. Your goal in designing a SCADA application should never be trying to make your application look pretty. You want to make your plant run as effectively as possible and as safe as possible. Having an application like this is unsafe. If you're still meeting opposition to people wanting to move to a high-performance HMI screen, give your operators just one of these screens. Make a really good level 1 overview screen with the key critical components of their application. Give them the information like I've described here, and let them use them in tandem with their existing SCADA screens. Talk to them after about a week or 2 and see if they want to go back to using their traditional overview screen. If you want to know more about designing a better SCADA application or high-performance HMI, all this information, of course, is based on the High-Performance HMI Handbook. It's on Amazon and from a lot of retailers. So I definitely look into that if you want to know more. If you have some ideas or some feedback for the types of things that you've learned in designing SCADA applications, or if you want to know more, leave us a comment and we'll get back to you. Thanks.